Hello, in this video we're going to learn about more multiplication properties of exponents. We're going to start off with power of a power. So as you can see here, when there's a base that is raised to a power and then both of those are raised to another power, we call that power of a power, and you write the base and then multiply the exponents. So I can prove that to you fairly simply with this problem here. So using this rule, we would say that x to the third then raised to the fourth power would be the same as x to the 3 times 4, or x to the 12th. It's pretty easy to prove, considering x to the third is just x times x times x. And if we do that 4 times, 1, 2, 3, 4, you can easily count that there are 12 x's, therefore x to the 12th. So power of a power is multiplying the exponents. Remember the previous video, we were adding the exponents, and that was when we had something like a to the m times a to the n, right? See the difference? Okay, here we were just multiplying two bases with different exponents. Here we're actually raising a power to another power. So how does this work when we get down to the green one? Pretty simply, actually. It's just x to the 2/3 times 1/2. Then you can fruit ninja the 2's here, and the answer is just x to the 1/3 power, or the cube root of x. Okay, moving on. Here we have multiple things going on. We have powers being multiplied together, and then we also have power of a power. When dealing with multiple exponent situations, use the order of operations. So deal with the multiplication stuff first, which is going to be this, right? And so we'll go with y cubed, we'll just write that again, and then y to the 2 to the 4th is going to be y to the 8th, right? 2 times 4. And then we can add the exponents and finish with y to the 11th. Again, if you get confused and you can't remember what's going on, always revert back to writing it all out. So y squared, well, here we have y to the 3rd, so that's just that, right? And then y squared to the 4th is y times y 4 times, right? So although it looks a little noobish, it's better to do it this way than to get the answer wrong. Eventually, with enough practice, you should be able to go pro style and get it this way. But if you forget, it's all right here for you, 11 y's. All right, let's do this next one. Again, we have multiple rules happening here, so I'm going to deal with the multiplication first. So we have y to the negative second, and then w to the negative second. And then we have 5/3 times 3. We'll do a little aside here and show you that that is just 5. So w to the 5th. And then we're just going to add those together and get w to the 3rd. Let's move on. So now we have another rule. It's called power of a product. It's different than the previous two rules. You can see that in the parentheses here we have two things being multiplied together, and then it's being raised to a power. This is similar to the distributive property of multiplication in that the exponent will affect everything inside. Don't confuse it with the distributive property, because the distributive property of multiplication, let me do a little aside for you here. The distributive property of multiplication says something like, we're multiplying to everything in the parentheses, 3x plus 6. Okay, whereas this rule I'm telling you now says something like 3x squared equals 3 squared times x squared. Okay, do not confuse this, well, which will be 9x squared. Don't confuse this with something like this. Okay, this is not true. Okay, this is not true. And notice in the rule we're dealing with right now, these things are being multiplied. It's called the power of a product. Okay, this is not a product. This is an addition. This rule does not work. Do not try it. It is not the distributive property. Okay, so going back. So we have power of a product. This 3 is going to affect both things, and we know that the answer is going to be x cubed y cubed. I can prove that very easily by showing you xy to the third power really means this by writing it all out. And clearly there are 3 x's and 3 y's. Okay. So when we get to this next one, we know that this will be 3 to the 4th times x to the 4th, which, well, 3 to the 4th is 81. So that is the simplified answer. Okay, moving along. Let's see, we did that. Okay. Again, this 3 over 2 is going to affect both terms, or sorry, both products, both factors. I'm getting my verbiage all mixed up. So these are factors because they're being multiplied. So this will be 9 to the 3 halves power times x to the 3 halves power. Remember, a fractional power means, well, the bottom number is what times what is going to equal 9, so that's 3. And then 3 to the third power is 27. So we have 27x to the 3 over 2 power. All right, let's try again. So here we have an application of this. So let's say we have a square of side length 7x to the 4th power. The area of the square is, the formula for that is side times side, or side squared. So to find this area, we would need to do 7x to the 4th squared. And so we'd have to apply this exponent to the 7, but also to the x to the 4th, right? And so the 7 squared is 49, and the x to the 4th squared is x to the 8th, because that's power of a power. Alright, let's try something like this. This looks like a crazy mess, but it's actually not so bad. Just take it one step at a time. So if we look at the left here, that's just power of a power. So we have n to the 1/2 times 10, right? Which is n to the 5th. And then in here, an interesting thing will come up. Notice this negative 2/3 power. It's above the n. An exponent only sees what is directly beneath it. Okay, so over here, this 10, let's back up a little bit. So right here, this exponent 2, it sees the parentheses. And so it's saying, oh, I need to affect the whole thing in the parentheses. Okay, whereas this x, this 4 here, is only seeing the x. It does not affect the 7 in any way. And that's why the 7 was able to be broken away from that 4. Okay, same thing's going to happen here. This negative 2/3 is only in effect with this n here. The 3, however, affects the 4, the m, and the n. Okay, so let's deal with those separately. So we have 4 to the 3rd power. We're going to have an m to the 3rd power. And this n is to the negative 2/3 times 3, right? And so we can fruit ninja that. So it's going to end up as a negative 2. So we have a 4 to the 3rd, which is 64, I think. And then we have an m to the 3rd. And then we have an n to the negative 2. So now we have 2 more things that can be simplified. So n to the 5th times n squared is n to the 5 plus negative 2. So that is n to the 3rd. And then we have 64. That always is going to go out front. We have m to the third. Okay, so we got all that. Actually, I'm going to put this in a different order. It should be in alphabetical order. So there we go. 64 m cubed n cubed. Again, it was a lot of stuff going on, but if you keep it organized and you show your work in an organized way, it's actually not too bad. So with practice, you'll definitely get it. Thanks for watching.